Hello everyone. Our lesson today talking about areas and volumes of similar solids. We studied before the similar figures have the same shape but not the same size. The same as the similar solids have the same shape and their corresponding dimensions are proportional. Here, by looking at the second part, what about the ratio of corresponding linear dimensions of two similar solids? The ratio of the corresponding parts, this is called the scale factor. Are the two rectangular prisms similar? If so, what is the scale factor of the first figure to the second figure? By looking at the first pair of solids, here to figure out if the two solids are similar or not, we will find if the scale factor, the simplified fraction, the same for all corresponding parts or not. Let's check if this is the same or not. By dividing this 3 by its corresponding side 6, 3 over 6, we will get 1 over 2. By finding the other fraction, by comparing the other two corresponding sides, 2 over 4, we will get the same ratio, the same simplified fraction, 1 over 2. Since both of them they have the same scale factor, then the first pair of solids, they are similar. But by looking at the other two solids here, the pair of solids, let's divide this side 3 by its corresponding side 6. We will get 1 over 2. But is this equal the side 2 over 3? No, not equal. Not equal the same scale factor. Then these two solids not similar. Here, by looking at these two cylinders, are the two cylinders similar? If so, what is the scale factor? Here, by looking at this height 12 and its corresponding height 10, if we divided both of them by comparing both of them, 12 over 10, after simplifying, we will get 6 over 5. And also by dividing this radius and its corresponding radius in the other solid, we will get the same scale factor, 6 over 5. Then both of the two solids here, the two cylinders are similar. By looking at these two prisms, rectangular prisms, here the first one, its surface area 22 square meters and volume 6 cubic meters. The surface area of the second one 88 square meters and the volume 48 cubic meters. Here, according to the given surface area and volume, look at the two solids at the first. Here, the two solids, are the two solids similar or not? Here, the side 2 and the side 4, 2 over 4 equal 1 over 2 after simplifying. And the side 1 and its corresponding to also 1 over 2. The third one 3 and its corresponding 6, then 3 over 6 equal 1 over 2. Then the ratio of the side length or the scale factor here is 1 to 2. By comparing their surface areas 22 to 88, after simplifying we will get 1 to 4. And by comparing their volumes 6 to 48, we will get the ratio 1 to 8. Here, by looking at this theorem, we have theorem if the scale factor of two similar solids was A to B, like 1 to 2, then the ratio of their corresponding areas will be A squared to B squared. If we squared this ratio 1 to 2, we will get 1 to 4. Then our theorem confirmed this fact. The other ratio, the ratio of their volumes, here if the scale factor A to B, then the ratio will be cubed, A cubed to B cubed, like this one. The scale factor 1 to 2, If we cube both of the two terms, we will get 128. By looking at this example, the square prisms at the right are similar, both of them similar. What is the scale factor of the smaller prism to the larger prism? Here, as we see, we have two volumes. Volume 729 cubic centimeters and the other volume 1331. Here, according to that we have volumes, then remember to write the ratio of volumes a cubed to b cubed, and a cubed to b cubed equal the two volumes 729 over 1331. To find the scale factor, then we need to find a to b. Then we need to find the cubic root of 729 and the cubic root of 1331. Then a over b, the scale factor is 9 over 11. What is the scale factor of two similar prisms with the surface areas 144 square meters and 324 square meters? Since we have surface areas, then we will write the ratio of the areas a squared to b squared, and we will write 144 over 324. To find the scale factor, remember, to find the scale factor we need to find the square root of 144 and the square root of 324. Then a over b equal 12 over 18. After simplifying, we will get 2 over 3. Then the scale factor of these two prisms is 2 to 3. What about the other example? The lateral areas of two similar paint cans are 1019 square centimeters and 425 square centimeters. The volume of the smaller can is 1157 cubic centimeters. What is the volume of the larger can? Since we have two areas, let's write the ratio of areas, a squared to b squared. This equal 1019 over 425. Again, remember, to find the scale factor of the areas, we will find the square root of the two areas, 1019 and 425. And to find the ratio of their volumes, then the ratio of the volumes, as we said, is a cubed to b cubed. Then let's write this ratio a cubed to b cubed of the volume larger and the volume of the smaller equal the first 1019, the square root of 1019, we will make it cubed because we need to find the volume. And also similarly, we will make root of 425, we will make it cubed. We will make it cubed, remember that. Then let's make substitution. Instead of volume small of the smaller solid, we will put 1157, and we will put our ratio the square root 1019 cubed over the square root of 425 cubed. By solving both of these two terms by proportional or cross product, we will get that the volume of the larger is about 4295.47. Let's solve the next question. This problem, the volumes of two similar solids are 128 cubic meters and 250 cubic meters. The surface area of the larger solid is 250 square meters. What is the surface area of the smaller solid? Since we have volumes of both of the two solids, let's write the ratio of volumes a cubed over b cubed equal the given volumes. To find the scale factor, then we will make what? We will find the cubic root of the given volumes. Then to find the area, the ratio of the area of the smaller over the area of the larger equal the scale factor but squared. The cubic root of 128 squared and the cubic root of 250 squared by making a substitution of the area of larger to 150, and by putting the ratio, the same ratio, after making them squared, because we need to find the area, we will solve using proportion to get the area of the smaller equal 160 square meters. Look at this problem. Marble paper weight shaped like a pyramid weighs 0.15 pounds. How much does a similarly shaped marble paper weight if each dimension is 3 times as large? As he said here, 3 times as large, then if we put the scale factor A over B, then according to this part, he said 3 times as large, then 1 to 3. The smaller is 1 and the bigger is 3. This is the scale factor. Let's use the scale factor. Since we need to find the volume, here we have volume 0.15 pounds. This is volume. Then we need to find the other volume. Then we will write the ratio of the volumes, a cubed to b cubed, but we will make the scale factor cubed, then 1 over 27. Let's write the volume of smaller over the volume of larger. Here we have the smaller, the volume of the smaller according to the given information, 0.15 over the volume of the larger. This equal 1 over 27. By using cross product or using the proportion, we will get the volume of the larger equal 4.05. Look at the last question. Which two of the following cones are similar? What is their scale factor? Here, by looking at the first cone and the last one, cone 3. Here, by looking at this radius 20 and its corresponding in the other solid is 30. By dividing both of them, we will get 20 over 30. After simplifying, we will get 2 over 3. Let's check by dividing this height 30 and its corresponding 45. Let's see if we will get the same scale factor or not. 30 over 45 equal, after simplifying, 2 over 3. Since the two solids, cone 1 and cone 3, they have the same scale factor, then both of them similar. Then cone 1 similar to cone 3. Thank you for listening and have a nice day.